Sometimes your real-world data will contain outliers, and they might be legitimate outliers. They might be caused by real people and not by some sort of malicious traffic or fake data, and you'll have to decide how you're going to deal with them. So sometimes it's appropriate to remove them, sometimes it isn't. Make sure you make that decision responsibly. So for example, if I'm doing collaborative filtering and I'm trying to make movie recommendations or something like that, you might have a few power users that have watched every movie ever made and rated every movie ever made, and they could end up having an inordinate influence on the recommendations for everybody else. And you don't really want a handful of people to have that much power in your system. So that might be an example of where it would be a legitimate thing to filter out an outlier and identify them by how many ratings they've actually put into the system. Or maybe an outlier would be someone who doesn't have enough ratings. Or we might be looking at weblog data like we saw in our example earlier, where we're doing data cleaning. Outliers could be telling you that there's something very wrong with your data to begin with. It could be malicious traffic, it could be bots or other agents that should be discarded that don't represent actual human beings that you're trying to model. But if somebody really wanted, say, the mean average income in the United States and not the median, they specifically want the mean, you shouldn't just throw out the billionaires in the country just because you don't like them. The fact is, their billions of dollars are going to push that mean amount up, even if it doesn't budge the median much. So don't fudge your numbers by throwing out outliers, but throw out outliers if it's not consistent with what you're trying to model in the first place. Now, how do we identify outliers? Well, remember our old friend standard deviation? We covered that very early in this course. It's a very useful tool for detecting outliers. In a very principled manner, it computes the standard deviation of a dataset that should have a more or less normal distribution, and if you see a data point that's outside of one or two standard deviations, there you have an outlier. Remember, we talked too about the box and whisker diagrams too, and those also have a built-in way of detecting and visualizing outliers, and those define outliers as lying outside 1.5 the interquartile range. So what multiple do you choose? Well, you kind of have to use common sense. There's no hard and fast rule as to what is an outlier. You have to look at your data and kind of eyeball it. Look at the distribution. Look at the histogram. See if there's actual things that stick out to you as obvious outliers and understand what they are before you just throw them away. So let's look at some example code and see how you might do that in practice. If you'd like to follow along, go on back to the Outliers notebook in your course materials, and we're going to revisit our example of income distribution data. So as before, we're going to use np.random to create a normal distribution centered around $27,000 per year with a standard deviation of $15,000, and we'll create 10,000 of these normally distributed incomes. And now, just to mess things up a little bit, we'll throw a billionaire into the mix, Jeff Bezos, whoever you want to imagine it is, and we'll just append that to the list of the income data that we have. Now you can see that this messes things up pretty quickly, even just trying to visualize this data. So as soon as we try to plot a histogram of this data, we see that all the so-called, normal people that are making around $27,000 a year are down here in this big spike here. And way out here at $1 billion, we have a single data point that you can't even see, but it's already messed up our ability to even visualize this data. So that one billionaire ended up squeezing everybody else into this single tiny line in our histogram. And it also skewed our mean quite significantly. So let's go ahead and run this to actually get that data in the system here. And if we compute the mean, we'll see that it's not $27,000 at all. It's more like $127,000 just because of that one outlier. So it's very important in a case like this to dig into what is causing your outliers and understand where they're coming from. You want to make sure that if you're throwing data away, it's justifiable. It's based on something principled, right? So if the purpose of this analysis was to understand the incomes of quote-unquote typical Americans, filtering out that handful of billionaires would seem like a legitimate thing to do. You just want to make sure you're transparent that you did that when you're presenting your data. Now, there is something a little bit more robust you can do than just saying, if you're a billionaire, I'm going to throw you out. We could say, for example, anything beyond 2 standard deviations of the median value in the dataset will be defined as an outlier. And we can choose whatever standard deviation value we want to there. So here's a little function that figures that out for us. I called it reject outliers. It starts by computing the median of a data set and the standard deviation of that data set. And this little line of code here just checks whether or not we're below 2 standard deviations of the median or above 2 standard deviations of the median, and returns a filter data set that throws them all out. So then we call filtered equals reject outliers income, And that just applies that filter function to the entire data set and returns the filtered set in its place. We can then plot that filtered data set and see if it works. Sure enough, it does. And the nice thing here is that it doesn't look like we threw out a whole lot of data, right? So we still have a nice clean little bell curve here, but our billionaire is gone without having to write any special logic that says, if you make more than $1 billion, we're throwing you out. Instead, it's based on a multiple of standard deviations, which is a little bit more of a principled thing to do. And our mean will be, well, more meaningful now as well. Let's go ahead and run this before I forget. So now if we compute the mean of the filtered data set, that's back close to $27,000. Your results will be a little bit different because of the randomness involved, but we did successfully filter out our billionaires without having to hard code a special case for them. We're just very principled manner rejecting outliers beyond 2 standard deviations of the median. That's a reasonable thing to do. So here's an activity for you if you want to play with this some more. Instead of a single billionaire outlier, add several randomly generated outliers to the data. Pick a range of values there and just throw them in there. Experiment with different values of the multiple of the standard deviation to identify those outliers and see what effect it has on the final results. It's just an opportunity to get your hands onto this and play around with it a little bit more directly, if you will. So give that a shot if you want to, and then we'll move on.